Yeah, so we'll
Yeah, I
start
think we can,
this
yeah, we should
webinar
start
now.
now. Yeah.
Yeah, hello everyone. So on behalf of the ISPRS Technical Commission 5 Working Group 4, I welcome you all to this webinar. This is the first webinar of a series of 6 webinars. And to deliver the today's lecture, we have with us Dr. Sanjay Srivastava, who is the Chief of United Nations Economic and Social Commission for Asia and the Pacific. So I welcome you, sir, and thank you very much for kindly accepting our invitation and sparing your time to deliver the talk. I also welcome Dr. S.P. Aggarwal, sir, who is the President of the Indian Society of Remote Sensing and Chair of the ISPRS Working Group 4 in Technical Commission 5, and presently working as the Director of Northeastern Space Application Center of Department of Space and Government of India. And I also welcome Lakshmi ji, who is the President of the Student Consortium of ISPRS. So before we start, I would now like to request Dr. Aggarwal sir for his initial remarks and to say a few words about the webinar. Over to you, sir.
Thank you, Dr. Kundu. Most respected our speaker today, Dr. Sanjay Kumar Srivastava ji. In fact, he was my senior when I was studying in IRI New Delhi, and he was in ISRO, Indian Space Research Organization, as a deputy director. Currently, he is the chief of disaster risk reduction at UN ESCAP. And also Dr. Kundu, who is the joint secretary of Indian Society of Remote Sensing and secretary of Working Group 4 of Technical Commission 5 on disaster risk management. Ms. Lakshmi Thapa, she is the president of ISPRS Student Consortium, very important position. In fact, ISPRS always looked into the student consortium. So thank you for joining and arranging this link to all the people. Dear attendees of this very important lecture from Chief of DRR of UN ESCAP, Dr. Sanjay Srivastava ji. So here, this webinar series was approved by the ISPRS during the midterm symposium, which was held in Manila last year. And at that time, we thought that we should invite the very eminent persons to deliver the talk, so that our participants will be benefited from our webinar. There are 6 webinars, and first will be today only by the Chief of DRR UN ESCAP. It is on importance of comprehensive disaster and climate risk management. Then second webinar will be given by Professor Adam Saeed Parites. Parite is basically, he is from Professor of Geospatial Intelligence and Mapping Lab of University of Waterloo, Canada, Ontario, Canada. He is going to talk about the geospatial infrastructure management ecosystem to determine the building vulnerability and risk estimation. The third webinar will be given by myself only on understanding the disaster risk and geospatial technology for effective disaster risk reduction, the Indian experience. The fourth webinar will be given by one of the very important person. He is Dr. M. Mahapatra. He is the Director General of Indian Meteorological Department of Government of India. And he is responsible to predict the monsoon or any, weather prediction he used to give. His entire department gives to the people of our country. And he's going to talk about space technology for combating hydrometeorological disasters. Then fifth webinar will be given by Professor Victor Lagutov. Professor Victor Lagutov is a professor in Department of Environmental Science and Policy, Central European University, Budapest, Hungary. And he is going to talk about environmental protection as an integral part of disaster risk management. And finally, because it's an era of the AI and now it is no more geospatial technology, it is the geospatial artificial intelligence. So a final topic will be covered by Dr. H. Lexi Young. She is basically from GeoAI group of Oak Ridge National Laboratory of USA, and she is going to talk about GeoAI for disaster risk reductions. So these are the 6 webinars we have planned, and it is starting with a very, very eminent personality, Dr. Sanjay K. Srivastava, Chief of DRR of UN ESCAP. So thank you very much, everyone, for joining this webinar. Thank you. Kundu.
Yeah, thank you, sir. I think before we start it, of course, Dr. Sanjay Kumar Srivastava sir need no introduction, but still I will take a couple of minutes to briefly introduce sir to the audience. So it's really an honor to introduce sir, Dr. Sanjay Srivastava with a PhD in Applied Physics from Indian Agriculture Research Institute. Is presently the Chief of the Disaster Risk Reduction at United Nations Economic and Social Commission for Asia and the Pacific, known as ESCAP. He oversees the ESCAP program of work related to disaster risk reduction and management of resilience and sustainable development. So before that, he was the ESCAP regional advisor on disaster risk reduction from 2009 to 14, and then head of the SARC Disaster Management Center at New Delhi from 2007 to 2008. And prior to this, he also worked as the Deputy Project Director of the Disaster Management Support Program at the Indian Space Research Organization, ISRO headquarters since 1991. While he was in ISRO, he is a recipient of ISRO's Team Excellence Award in 2008-9 for his contribution towards harnessing space technology applications for the benefit of rural poor. He has more than 150 research publications on disaster risk reduction, including research papers and peer-reviewed international journals and intergovernmental reports and books. Sir has been a lead author of ESCAP's flagship publication on Asia Pacific disaster reports since its inception in 2010, as well as the WMO's State of Climate publications for Asia and Southwest Pacific. So therefore, he brings a vast experience in the field of DRR as well as climate science, and therefore today's talk on the importance of comprehensive disaster and climate risk management is, I'm sure, it's going to be a great blend of two key challenges that the humankind is facing today. So with this, I welcome you once again, sir, and request you to kindly deliver the talk. Over to you, sir.
Yeah, thank you, Kundu, and my sincere thanks to Dr. Aggarwal, my dear friend, my colleagues in the past, to ISPRS community, to Dr. Kundu, Lakshmi, bringing me back to the ISRO fold, to ISRS community. I've been a life member of ISRS, and it's such a pleasure to come back to our roots. So when Dr. Agrawal sent this to me, it was such a pleasant surprise because when you revisit at some point of time back to the place where you acquired your knowledge, your skill, it always makes you feel a bit nostalgic, but it's internal pleasure that I'm coming back and trying to make sense what I'm doing is relevant to the community of ISPRS. So thank you very much. I thought, how should I present is topics which Dr. Agrawal has chosen for me. This is the topics I have been working here day in, day out. It's a part of my job description in United Nations system. So I thought, let me bring some perspective from the UN side, because UN as such is the United Nations. It's experiences of countries all around the world. And here in Bangkok, it's the experiences of Asia Pacific countries. So on comprehensive climate and risk management, what are the experiences of the country? How they are managing the climate and disaster risk, and especially with geospatial tools, techniques. So let me share my presentation, and I
Yes, sir, it is visible.
yeah, it's visible. Okay, thank you.
You may kindly make it full screen, sir.
Yeah,
full screen. I mean, it is only.
Okay.
It's loading. I think full screen mode is coming very soon. I can see you have already clicked
So
it.
that's
Okay.
But now I
Is it-
think you've clicked somewhere. So maybe I would like to request again to click the full screen mode.
Yeah,
The one you clicked before.
Right.
On the right side bottom, normally.
Yeah.
Right. Let me try again.
The one next to Zoom scale. Yeah,
This
perfect.
makes,
Perfect. Sorry.
this is one?
Right, sir.
Yeah, this is fine.
This is fine? Okay, thank you. Thank you, colleagues. So the disaster and climate risk management, the practices in the region, the trends. So let me start with this is an era of climate disaster emergency. I think you are looking at the news every time, but this is what the UN system, I think, is dealing with, the era of disaster emergency, which is compounded by the climate change. If I share with you the risk escape of disasters worldwide, among the different geography of the world, Asia Pacific is the most impacted. You see the left-hand part of my slides, which shows the overall impact of disaster. And see, from 1970, 2 million people lost life in the Asia Pacific, which is more than 50% of the global fatality. And here, the point I wanted to flag to you is you see the disaster-related economic impact percent of the GDP of the region. In Asia Pacific, this is the highest. And this is also the growth engine of the world. You see the major economies, China, India, Japan, these are all in this region. And the growth engine, when gets impacted with so much loss, the message is the faster we are growing, we are also losing faster. And this is not sustainable. This is something which will derail the progress. The more you grow, the more you lose is not sustainable. So this is what happened in last 50 years. But when you look forward, with all climate scenario projections and models, this is what we have done here in ESCAP. With 1.5 degree warming, which is today's, the whole Asia Pacific, 85% of the population are at risk. And when you do a econometrics modeling, 924 to 956 billion dollar is per annual average loss, which includes the direct losses as well as indirect losses. So this loss is quite substantial. But the moment you go little more warmer, which is likely in coming few years, at 2-degree warming, this loss gets multiplied. The important point which I would like to flag is if you see down here, these are the risk maps, multi-hazard risk hotspots. So the losses are not uniform across all the geography. There are places where loss gets amplified. There is the highest loss. So the risk is not uniform. It's concentrated in certain multi-hazard risk, what we call multi-hazard risk hotspots. I will come a little later. This is where geospatial becomes very important to capture those hotspots. So the key point is in the era of disaster emergency, when the country's aspiration is to grow faster, become a developed countries, from middle income to developed country, the disaster losses many times derails the aspiration. And that is something needs to be arrested. So what I would like to tell you is, you see I'm talking about Asia Pacific region. This came from our publication, the flagship publication, Seizing the Moment. You look at 1.5 degree to 2-degree warming and see which part of Asia and the Pacific where disaster impacts are going to be multiplied many-fold with the warming. And you look at here, some small island developing states like Kiribati, Nauru, New Caledonia, Papua New Guinea. These are the island country where the warming, particularly the convective system in the Pacific Ocean, is going to multiply the risk many-fold. Another point here is, these are the countries which were located already what we call in the Pacific Ring of Fire. 90% earthquake happens in the Pacific Ring of Fires. Now, these are already at a high seismic risk. Now they are going to see climate risk as well. These are the typhoon tracks, the tracks of active tropical cyclone, which were never there in the past. So the tropical cyclone and seismic risk both converge. and creates a kind of scenario where the disaster and climate, the climate and geospatial hazards brings huge risk and vulnerability to such countries, especially the names which I listed, Kiribati, New Caledonia. So this is about the geography of the risk. But what I thought I highlight, particularly for this presentation, is something which UN system has in last few years is making lot of impact worldwide. That's what is called loss and damage, climate induced loss and damage. You see the disaster related impact. Normally the disaster related impacts are some impacts which you can mitigate with your better preparedness, with better policies, programs, capacity. So those are the disaster loss which you can mitigate. There are some disaster losses which you can adapt with your better land use planning, agriculture, water systems, so you can adapt. But there are disaster losses which you neither mitigate nor adapt, which are the permanent loss. You will never recover for this. So this permanent losses is something goes beyond one generation to other generation, many generations lived with this kind of what is called irreversible impact. So that is what is called climate-induced loss and damage. And in today's context, they call it should attract climate justice. That's the perspective to look at climate-induced loss and damage. So that is the loss and damage which you cannot recover. So this put together is a big impact of disaster and climate risk on the people, on the community, and you see the geography where the impact is much more severe. Now, if I come,
I'm so sorry. Can
Yeah.
I interrupt you? Sorry to interrupt you.
Yeah.
We are seeing your notes and next slides mode as well. May I request you kindly to change to, like, if you see at the bottom, there are like 4 or 5 buttons, right? I think if you
Yeah.
click just hide presenter view, I think we will just see your slide. Or if you click like there is the one button like zoom, no, over there on the same area.
Here?
Yeah. If you click the one next to the symbol like zoom one, can you go on the left? The one next to that, the right, sorry.
This one?
No, another one.
This is the zoom, huh?
Yeah, the
Zoom
another
into
one.
slide.
Sorry, another one.
This
Yeah.
one.
Click
this?
No, not again. Sorry, can you stop
Okay,
it?
sorry.
It does screen sharing.
Ha,
Not
ha.
again. Sorry. No, not even this one. No, can you click the more one? Sorry for this.
Okay, yeah.
The 3 dot button.
Yeah, that
3
is
dot button, and then hide presenter view. 3 dot button. The one next to that, the right
next
one.
Next to the video, huh?
Yeah, the one on the right of that.
Just 1 second.
There is this circle and 3 dot.
I think it has disappeared. Let me see.
I think you have to do stop screen sharing. It looks like you're.
Okay.
Yeah. Now, if you share the slides, sorry for this trouble.
Right, no problem. I'm not much familiar with Zoom. We deal mostly with,
Yeah,
with,
yeah. Sometimes
team,
because of different
team.
platforms. It's
Now
now
you
it's
tell me.
perfect. Yeah. Thank you
Yeah.
so much. Sorry.
Now
Please.
now it's okay?
Yes. Yes.
Yeah.
Nice.
Sorry.
Right. So, I was coming from loss and damage. Now, the topics given to me is what to do to prevent this whole disaster impact. That's what is climate risk, climate and disaster risk management approach, comprehensive one. So what world has been doing in that direction is they take some policies which are related to what we call mitigation, policies which can avert the disaster. And one policy at global level is you somehow, what is called the emission level, you can reduce, brought it below 1.5. So this is the policy related to mitigation. The second policy that follows is adaptation. So for adaptation, you invest in the early warning system, resilient food, water, energy systems, many sector-specific, nature-based solutions. So country have been doing this. Some country, very few country rather, are working on loss and damage. This is what I told, irreversible disaster impact. For example, sea level rise, the glaciers melt, the desertification expanding much beyond a limit where it can be brought back. And then there are residual risks which are also related to the vulnerability. So there are range of climate related impact. So you need a policy to avert, which is mitigation, minimize adaptation, address, which is the humanitarian action. And then all put together is what is called the comprehensive climate risk management approach. Where it is working, this is a very idealistic situation where you have an emergency response, you have a very high quality dedicated disaster response force, you have loss and glaciers melt addressed through science, through monitoring, through early warning systems. Then you have bridge adaptation grab with enhanced adaptation in agriculture sector, water sector. Then you have the huge, what we call the avert disaster to, particularly for controlling greenhouse emission. So all put together becomes the part of the climate risk management approach. In climate risk management approach, I want to share with you what UN system has been doing, and then all countries to some extent follows this UN framework on climate risk management. There is a UN 3-4 framework, which all of you are aware, but I want to focus this from a climate risk management perspective. 2030 Agenda for Sustainable Development, which comprises Sustainable Development Goals. The another one is Sendai Framework for Disaster Risk Reduction, and then comes to the Paris Agreement, which deals with loss and damage. The Sendai Framework was not very explicit on loss and damage, nor the SDGs. So all put together is a very comprehensive global framework that addresses climate risk management. So it has everything to address in a very comprehensive way climate and disaster risk management. But if you look at the progress, so I'm just trying to flag, this is the latest Sendai target where countries stand. So if you look at Sendai target, for example, the target 1, that is the mortality. Countries have made good progress thanks to the early warning system. We have been able to bring down mortality to a certain extent, particularly in some of the disasters like tropical cyclones. So good progress. Also, there is a good progress on disaster risk reduction strategy, E. Good progress on early warning systems. So A, E, G are the targets of Sendai where world has made good progress. There are limited progress on the number of people affected, and then the international cooperation. And this international cooperation, ISPR is one of the example of cooperation among the professionals of geospatial areas. So this many layers of the cooperation contribute to disaster risk reduction. But where the challenges lie is, see, the economic losses is going to the roof, not been able to contain yet. Then the losses to the critical infrastructure, that's the cause of the concern because that's multiply the overall impact. But the bigger challenge is coming through the climate change, which is becoming more complex, compound, and cascading risk. So if you see the progress, our progress, this is the mixed bag of success all around. So if I share with you the progress, particularly on adaptation, because climate risk management is basically a climate change adaptation and disaster risk reduction. I am just flagging 3 flagship UN publications which captures where the world stands today. This includes India as well and many of ISPRS member countries. You see, in 2022, we bring out adaptation gap report at COP, the climate summit just before that. Here, the progress worldwide is too little, too slow adaptation. So you look at the progress in 2023, underfinanced, underprepared. You see the last year in Baku Climate Summit, come hell and high water. That shows the progress on adaptation is still a long way to go. So why I flag this to you is this is what UN system has been doing, the support to capture the trends and where the gap lies, where the challenges are. And that is where you bring some financial interventions, some technology related interventions. I will come back a little later on this front. Now I'm coming to what to do to put in place a comprehensive disaster and climate risks solution. What is the pathways? The pathway starts. I'm happy I'm talking to ISPRS student community. You should, I'm just telling you a complete picture, climate risks management solution. You will start this pathways with hazard and risk understanding, mapping, understanding, and providing the access to your risk information of past and future data. So that's the fundamental of taking climate risk management forward. You have been doing part of many ISPRS work, mapping out hazard, understanding the risk. Now the second part is on impact. The impact part is it's not enough to understand where the hazard is, but what could be its impact on the people, on the economies. So these are the step number 2. The third milestone of this pathway is you focus, you align your development in such a way that the development has to be risk informed. So your policy response cannot be risk blind. It has to be risk informed. So that's the third step. The step number 4 is risk financing. You finance your infrastructure, for example, developing the infrastructure in mountainous range in such a way that it should able to withstand some level of the disaster risk. So you finance. And then you come to the risk governance in your country. That's where because it's not one ministry, not one sector, multiple sector, overall country disaster and climate risk management governance framework. These are all the pathways which starts from recognizing, understanding the risk, then comes to risk analytics, then risk-informed development planning, financing, and governance. So these 5 dots, if you connect, that what becomes a comprehensive disaster and climate risk management solution. In your ISPRS experience, you have been dealing with all these dots, and at country level, the idea is to put all these dots together to make a difference, to impact larger number of people. Now coming to the risk understanding the hazard. I'm just flagging the previous IPCC report, which is a very good, I think, understanding on risk is no more a linear one, which normally in disaster community, what we do, we understand hazard, we understand vulnerability, we try to understand exposure, and then develop a risk. The whole policies program on understanding of risk, hazard, vulnerability, exposure. Now what is happening due to this 1.5 degree and beyond warming, risks are becoming more complex. It also compounds and cascades across the sector. So the reality on ground today is complex, compound, and cascading risk. So the principle of risk management, which we have been dealing with, hazard, vulnerability, exposure, and risk, is now changing. So this is the change which we need to understand. Risk is no more linear. If I tell you some of the fundamentals of this complex, compound, and cascading risk, here you see what I told to you. category 1, the simple linear understanding of vulnerability hazard exposure. But now what is happening, there is an interaction among the hazard itself. And then the hazard, just a second. Hello. Sorry for the interruption. So what I'm trying to tell you, the science of cascading compound and systemic risk is the hazard itself for interacting with each other. So the interactions are not unilateral, but bilateral. And that makes understanding risk very, very complex. If I cite by just one example in your neighboring state in India, 2023, this is a cloud burst in Lohang Lake, North Sikkim. And you see this complex compound risk example in a mountainous context. Normally risks are very complex. They compound and cascade. Here you see it started with cloud burst, and then this hit a hydroelectric power plant and destroyed 1,200 megawatt Ujra hydroelectric power plant. But it was not only cloudburst and the energy sector. The impact downstream, this was hundreds kilometers away, is so critical because it impacted the overall economic flow from Sikkim to the downstream regions of Bengal and other part of India. And then it started with the impact on energy sector. And because of disruption of the economic flows, it impacted many sectors. So you see, you can do a GLOF early warning system fine. But the GLOF early warning system, if it is very effective, very precise, pinpointed, and if you could able to prevent this GLOF, you prevent many of the compound and cascading risk downstream. So the important part is to understand the linkage of GLOF early warning system to many other related sectors of the economy. So this is a very unique example of complex and compound risk. My second point is, as I mentioned to you, in the climate risk, comprehensive climate risk management, the more important point is how you are visualizing the risk. And that's where the geospatial role is so important. See this example I'm citing of Maldives. When you take a IPCC data of Maldives, mostly available in the public domain, it's 100 kilometer by 100 kilometer, and you look at the projection of the islands in the Maldives, you hardly see any risk because of the resolution. You normally don't see what is going to be the risk in Maldives in coming days. But the moment you downscale the 100 kilometer to 5 kilometer, you see the red zones. Those source, this is the IPCC CMIP6 model. You can look at the granularity of the risk in different islands. So you visualize the risk with your science, with your risk analytics, and help the country to prepare for their adaptation level planning. The second example is the example of Bhutan. Here again, you take the IPCC data, which is available in the global database, and look at Bhutan, particularly the agriculture sector of the Bhutan. From the globally available data, you can't see, this is what you can see here, you hardly see any risk in Bhutan's agriculture. But when you downscale this to 1 kilometer, 1 by 1 kilometer, you see the risk to agriculture system in Bhutan with a lot of granularity. So when you are developing a comprehensive climate risk management for agriculture sector in Bhutan, you need to have this kind of understanding at a granular level in a different time zone. Like this is by 2050, 2060, what could be the pattern of the risk in Bhutan. So the government of Bhutan, when we were working with this, they were very keen that they don't want only to look at the spatial part of the risk visualization. They wanted to see the risk during the monsoon period, because most of the disasters that Bhutan experience are during the monsoon season. So monsoon season, you'd see you downscale from a spatial side. Now you are downscaling this from the temporal side, from the temporal perspective to capture the risk in Bhutan during the monsoon period. So this is what you can see, the risk to agriculture system in a high granular, spatial as well as the temporal resolution. Downscaling climate risk, supporting climate action, adaptation, and is one of the key imperatives in today's world of climate resilient future. This I took it from our experience because I'm talking to our colleagues who are there in Assam and in Meghalaya. This is the work we did as a part of SDG, Sustainable Development Goal, localization in India. India is one of the few countries who has developed SDG localization, SDG index at district level in few parts. Northeastern part of is one such. This is, I think, the big reference work on SDG localization worldwide. So you have a SDG number, index number, for northeastern state. So when disaster hit, let us say Assam flood of 2022, May, June, massive, how it impacts SDG numbers. When you look this from a perspective of, let us say, planning ministry of the Assam government or the government of India, you see SDG goals. For example, SDG goal, which is related to poverty, SDG 2, which is related to food and hunger. You see in one disaster, for example, one flood, the impact on SDG 2, SDG 13, which is climate action, you can narrow down, pinpoint how disaster impact the progress of SDG in a place like Assam. So when you look at with so much granularity, the impact of disaster on SDG down the line at district level, your policies and programs, this has been factored in many of the development plans of the Assam government through Niti Aayog. Many of your programs and adaptation related programs try to turn it more disaster and climate resilient. There is a similar one on impact side. This we did it here in ESCAP. Cyclone Mocha, for example. This was a cyclone that originated basically from the Andaman coast, started moving from the east coast of India, Tamil Nadu, then Andhra, then Odisha, Bengal, finally went to Bangladesh, and then before its landfall, it reached to Myanmar. At every progression of the cyclone, you capture the number of people who are likely to be impacted when the cyclone was very close to Bengal. Number of people just 12 hours later is came very close to Bangladesh. Most of the predictions was this is going to hit Bangladesh, the place where Rohingya refugees numbers are quite, Cox's Bazar is quite large. Finally, it landed to the Myanmar part. Now you see, because you could able to map the impact, the number of people who are on the tracks of the tropical cyclone, the agencies in the government, they evacuated those people immediately. And before the cyclone hit, the number of people who were directly exposed to the cyclone track, they were evacuated. Mind it, this is the same part of cyclone in Myanmar in 2008, what is called Cyclone Nargis, one of the deadliest cyclone in the Bay of Bengal. 140,000 people died because of the cyclone Nargis. But there was a similar cyclone Mocha, which traveled across the boundaries of many countries. But when it hit Myanmar, one of the most vulnerable part of Myanmar, the casualty were bare minimum. It was 150, if I remember correctly, the media report. So you see, if you forecast the impact, you are in a better position to protect the people. So it's not predict the hazards, also predict the impact on the people, which help the agency to evacuate people on the risk. So that's a unique example of managing climate risk. Now, my second part of the presentation with few slides is what to do with the data and technology ecosystem to enhance the comprehensive climate and disaster risk management. Here, I want to tell you that all of you are familiar with. I'm just putting this in a context. The context is just one technology is not enough to accelerate the adaptation and comprehensive climate risk management approach. You look at the cluster of the technology. The cluster one comes from the science-related, science-intensive climate science, the advances climate models, particularly downscaling, all those, then health science, adaptation, modeling, simulation. So this is one point of the science which comes from many of the academics and research institutes. The second cluster is the traditional one. You build the huge infrastructure, water, energy infrastructure, transport, digital. So this is a core engineering hardware cluster 2. Cluster 3, which is emerging in today's context, is the data science and geospatial technology, Earth observations, risk analytics, early warning. Now, if you have to support a countries from a technology solutions to adaptation, you have to look at the three clusters. Make a very judicious as a policy planner in a particular country context, how to put cluster 1, cluster 2, cluster 3 technology together to support adaptation plan. My second slide is from World Economic Forum last year. In the extreme climate case, like for example, 2-degree warming, how technology can help the world. They listed 6 technology which can make a difference in the warming world. AI for climate adaptation, drone for climate adaptation. All of you are very much familiar with this. Earth observation, remote sensing, advanced computing, Internet of Things, augmented reality, and virtual reality. What I'm trying to say, many of these are very well established as a pilot project. What is challenge is to scale it up, to put it in a mainstream of the country adaptation and resilience pathways, policies, and programs. So there are many countries who are using all this in an operational domain, helping the line ministry to capitalize on these advances. Another point in the technology I wanted to flag is this process of innovation. The data and technology ecosystems, how they are coming together. For example, as you are all aware, the one side you have host of the technology, right from drone to Earth observations, everything. Now the advances in the cloud computing and the big data analytics all together. So these are all in a digital form. So the solution that exists today, particularly in a riskier context, is you need to have everything digital. And that's where, because when you are talking about the impact forecasting of tropical cyclone overall life cycle is 24 hours to 48 hours. So unless things are in digital domain, you will not able to respond. So this is important to recognize. It's all digital domain. But the real impact is coming from what my colleagues, Dr. Aggarwal, told in the beginning is with AI and machine learning, this digitalization process is becoming much more, the what is called the like a change agent in true science. Uh, Take AI in early warning for all contexts, advanced disaster knowledge, hazard monitoring, accelerate, boost disaster response, fair and all-inclusive. So these are some of the trends which can be captured. Let me cite one example, which many of you are aware in India. This is the case studies from the partnership of Central Water Commission with Google. And they use this AI, what they call the Flood Hub. And the Flood Hub with Google repository, Central Water Commission's the data from the multiple gaze locations, brought it together. The point which I told, it enhances your understanding of the risk, and also particularly in the early warning system, it multiplies the speed, accuracy, and the most important thing which I would like to flag, it takes technology to the household level, personalizes early warning systems, which were not there before. So with AI, we are taking this to household level. And Google examples, particularly in Brahmaputra Basin with Central Water Commission, is, I think, you know, better than me. But I just wanted to flag, once you have a partnership with AI company and Central Water Commission who deals with the hydrology, you can make a lot of difference using such technology. One example which touched everybody's heart last year was again the example from India. This is a Amrita school in Kerala. They have, you know, the most important part is how technology can avert a disaster, can really protect the life of the people. This is one example of a massive landslide in Kundu district in Kerala. And this is what they call the landslide early warning system. And this landslide early warning system was awarded last year as a prestigious disaster alert award. And this is again AI enabled Internet of Things, the sets Amrita early warning, particularly identifying the risk, and then the vulnerable community, engaging community in making early warning like a truly participatory. So many of the landslides, they could able to protect people. I think they are replicating this in Sikkim. I don't have updated information, but this made a lot of news last year when Disaster Alert Award was given to Amrita Early Warning System. This trend, you are quite aware that drone and Earth observations together are making a lot of difference on post-disaster impact assessment. And this is a trend which is catching up. There are many which you are already doing from the center. But what I wanted to flag is the data is not only available in one platform. Data are available in multiple platforms. For example, if you want to work on building resilient infrastructure, here the GIRI platform of Coalition of Disaster Resilient Infrastructure, it has a huge repository of infrastructure resilient data in a different hazard zone. Then ESCAP has a risk and resilience portal, which is a visualization of the climate risk. The examples I shared with you of Bhutan and Maldives. So bring both this platform data together to visualize the risk to the infrastructure. And that could be one of the most important climate resilient strategy when your infrastructure is resilient. My last point is look at what I discussed with you. Capture the trend. Adaptation or comprehensive climate and disaster risk management is not possible without technology. Technology is the key, and then comes to your financing, government policies and program, because everything, if you ask, will be driven by the capacity of a country to adapt to the state-of-the-art technology. So the trend here is the technology landscape is changing very fast. You know better than me, particularly what we started image processing, and now we are coming to ML, AI. So the landscape of technology is changing very fast, so its value and impact. The important point is, along with the technology, the data ecosystem is changing fast. So technology and data ecosystems are converging and embedding into digital globe. That's the very important reality, convergence of technology and data ecosystem. Now, the third point is the policies of the government. You can see this in India, the democratization of the platform. For example, ONDC, which is the e-commerce platform. So it's becoming democratized, everything becoming open source. Slowly, that's the trend is coming. So scaling technology and data ecosystem in a collaborative mode. That's the policy reform any government is taking forward. Most important point is now, who are the drivers of all this change, technology, data, democratization? the rise of the builders. Those rise of the builders include startups to innovate, operate, and lead in disaster technology for resilience. So startups, new young students, researchers, the institutions like the ISRO, they are going to play more important roles. So these are the rise of the builders. So these rise of the builders are basically the future for taking forward comprehensive disaster and climate risk in the changing climate, in the warmer world. My last slide is just 4 key takeaways. Capitalize on technology ecosystem, digitalization for better understanding of complex and potentially systemic hazard estimating for the climate change. That's the message number one. Number two is build and capitalize on a startup ecosystems to innovate, operate, scale frontier technology towards building resilience. Number three, technology and data ecosystems provide underpinning, evaluating risk, realizing people-centered early warning system, estimating loss and damage to support climate financing. Last is, as risks are always evolving, because as I told you in the beginning, 2.0 warming will have a very different risk than 1.5-degree warming. So the risk is evolving. Iterative process of monitoring, evaluation, learning can inform both understanding and management of the climate risk. So that's where the solution lies. And once again, my sincere thanks to Dr. Aggarwal sir and colleagues for giving me this opportunity to talk to ISPRS audience. So I'm here if there are any query, any questions. So thank you once again for this opportunity. Right.
Yeah. Thank you, sir. Thank you. It has been a real and excellent talk, sir, covering the complex and the vast spectrum of integrating disaster risk reduction and climate action. And you have very nicely covered how the emerging and disruptive technologies can be of help. So, sir, there are a couple of questions. There is a Q&A section, sir, at the bottom, or otherwise I can read those questions out for you. Or
yeah, please.
okay, sir. Yeah. So the first question was from Arundhati. So she was asking that what type of downscaling was employed for the risk assessment of our Bhutan, statistical or dynamical?
Yeah. Oh, I'm very happy, Arundhati, you asked this question. We, to be very frank with you, we could not go for dynamic downscaling. We had a partnership with NIES called National Institute of Environmental Studies in Japan. They have what they call Asia Pacific Adaptation Information Platform. There are tools to statistical downscaling of climate, especially CMIP6, the IPCC, the latest modeling scenario. They are one of the author of CMIP6. So we made use of their collaboration. They helped us to produce 1 kilometer by 1 kilometer resolution, which is amazing. Of course, it has certain limitations, but it was within the limit. We did a lot of validations with the help of Bhutan government. So it was a statistical downscaling model. AP-PLAT, you can refer this. AP-PLAT is a very famous acronym, Asia Pacific Platform for Adaptation Information Platform.
Thank you, sir. Yeah. So while we take other questions, I also request other participants, if you have any question, please put that in Q&A section. You cannot ask the question here. So please put that in Q&A. So, sir, the next question is from Prakash. He says that there are two questions. First is how can developing countries strengthen their early warning systems and disaster preparedness, considering limited resources and technological barriers?
I think, should we come out of the slides? So
yes,
more?
sir, that will be good. Yeah, if you can.
I think I tried from.
On the top only, there was a stop presentation.
Okay, yeah.
It has gone, sir.
Right, no, it has gone. Right. Yes, now I can see the questions as well.
Okay, Q&A is there. Yeah.
Right. Thank you, Q&A. So, if I come, thank you, Smith, hydroinformatics. WRD Assam. What is the
Sir, no,
link?
it is in the Q&A, not on the
Okay.
chat.
Okay.
Q&A.
Okay. Q&A. I think better you read. I'm not very comfortable with
Okay. Okay,
this
sir.
thing.
Yeah. So
Yeah.
already you have answered Arundhati question. So second question
Ah,
is by Prakash. He
ah,
says, how can developing countries strengthen their early warning systems and
mhm,
disaster preparedness,
mhm,
considering limited resources and technological barriers?
mhm. Uh, Prakash, thank you very much. The examples of Cyclone Mocha, which I shared with you, you can't expect Myanmar to have a state-of-the-art early warning system, but what has worked for them is IMD, which my friend Dr. Mahapatra will be talking to you. There is what is called a specialized meteorological system, RSMC, specialized regional specialized meteorological center. So they have the capacity to monitor all the weather satellite data, radar data, and many of the ground data, and process this information and disseminate through the network of hydrometeorological organizations, the government hydrometeorological. So they provide all the background information to them to take the decision. So point I'm trying to highlight, if there is a regional cooperation element, like I cited the example of Cyclone Mocha, if there is a similar mechanism for GLOF, you pick up, like if it is a Hindu Kush Himalaya, you take the example of agency in India or EC mode in Nepal, who could able to monitor the GLOF and who could able to develop, some what we call a advisory, and then inform the country on time. So, somebody is working on your behalf and helping you to prepare better. So, the one good thing that UN does is try to build on the capacity of the country and help the neighborhood. For example, if I want to make a very specific example, the Indian Ocean Tsunami Warning and Mitigation Center, IOTWMS. This is a vast Indian Ocean. Tsunami risk one country cannot manage, cannot understand. So it was Indian Tsunami Warning System inquires, the Indonesian Tsunami BMKG, and Australian Tsunami Warning, Indian Ocean Tsunami Warning. So three countries put together covers the vast of Indian Ocean region. So they provide, with all their capacity, tsunami warning, let us say in case of India, to Sri Lanka, to Maldives, to Sri Lanka, to Thailand. So these are the regional cooperation mechanism and framework, which helps the country to, even if they don't have their domestic capacity, through regional cooperation, they get all the expert advice.
Yeah. Thank you, sir. There is one question from PLN Raju. Sir,
Okay.
is
Oh, my dear
I'm sure
friend. Yes, yes. Yeah,
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 yeah.
yeah, yeah. Right,
Sir asked that this Amrita landslide early warning system. So what are the
right.
components, equipment, sensors, and how it works?
Uh-huh. I think the PLN Raju, I'm so happy you heard me. I'm so happy. We are a very old friend. This is what they call the Amrita has established a good network, the Internet of Things, and they have used. If you look at my slide, the early warning, the landslide early warning for Amrita is basically the sensor they have developed at a different level of the slopes. Understanding the stabilization of the slope, they did a lot of simulation, slope with rainfall, with different vegetation, and accordingly place the sensors. So that makes the network of the sensor through quite appropriate, quite precise. And this, because they have a institution working with them, the engineering college. So through a student, the Internet of Things, the whole the framework they use, and densify the sensor. The beauty of this, you have a very dense sensor network, and in those places where the land susceptibility or the vulnerability to landslide is the highest. So I think that's one reason of their success. Plus, they have worked with community. The details are there in the Amrita landslide early warning system.
Yeah, okay. You have already shared. You're just asking what is the cost estimate and success rate.
I think Dr. Raju, when this Wayanad landslide happened last time, there was a lot of concern because Amrita landslide early warning system was in Munnar in the different part of Kerala. Wayanad was a different part of Kerala. So the idea was we could have a similar system in Wayanad. So of course, this is a policies of the government because here it is a Amrita trust with the government. They have established this. So this need was felt in many parts. Now, Amrita landslide early warning system, I think they have moved. They are also collaborating with the Sikkim government. So it's very important to scale this. Yeah, right.
Right, sir. Sir, there are 3, 4 more questions. Should you take it, sir?
Yeah, please go ahead. Go ahead.
Yeah. So there is one question from Professor Rajesh Kumar. He says that during recent years, frequency of cyclone has increased in the Bay of Bengal and Arabian Sea. What are the basic reasons related to issues of climate change?
Hmm. I think this is no doubt. If you, Professor Rajesh, if you recall in earlier days of 80s, 90s, the Bay of Bengal used to have four to five cyclone in a year. Arabian Sea used to have hardly one or two, means not more than one. But today's situation has completely changed. In Arabian Sea, the frequency of cyclone has gone up quite substantially. In Bay of Bengal, the science says the frequency has not gone up much. But what has gone up and which is really dangerous is there is a rapid intensification. If there is a cyclone with 120-kilometer wind speed, just before the landfall, the wind speed goes up to 180 kilometer, 190 kilometer. So this rapid intensification is because of this sea surface temperature, then atmospheric water vapor put together, and these are all due to the climate warming. So in Bay of Bengal, it is a rapid intensification, which is a challenge for early warning system community. In Arabian Sea, is more cyclones. So those countries never prepared so much for the cyclone, especially the Middle East Gulf country. Now they are exposed to the cyclone. We have a panel on tropical cyclone, and the Gulf country were never member of this because they thought cyclone will never hit them. Now they are all part of the panel on tropical cyclone. So this is a new reality. Yeah.
Thank you, sir. Yeah. There is one question by Dr. Arup Bargohai. He says that does disaster management strategy include plastic waste management? He says that I feel plastic waste has become a disaster for Mother Earth, directly or indirectly, and it is linked to other disasters.
To be very frank with you, I don't have much idea on this side because they look at from a ocean pollution, marine pollution perspective. So of course, if a area which has a high pollution, plastic pollution, naturally, if that area also happens to be on a tropical cyclone pathways or maybe tsunami related, so it's I will not able to justify in my response because I have not seen the link between these two.
Right. Yeah.
Right.
There is one question by Dr. Tausif. It says, how effective is the nature-based solutions for the
Right.
climate change adoption in developing countries?
Yeah, it's very, very effective. But that's not the only solution. The experience is you should have nature-based, what is called green, also gray. Huh. Green, gray together, and that has to be in a very strategic way. For example, in Bay of Bengal, there were quite a bit of studies. If there is a storm surge, and there is a 120-kilometer wind speed, you have a mangroves or the nature-based solution that will able to withstand this 120, and then the storm surge to a certain, uh, I don't exact number, but it has a capacity to combat it. But if cyclone becomes 160, 170, and a storm surge becomes much bigger, then the green infrastructure or nature-based solution is not enough. You need coastal protection with nature-based solution. So it has to be used very judiciously, and that's where the understanding of the risk in a particular location is very important, very critical.
Right, sir. Thank you. There are 3-4 more questions are coming actually. One question from Champs Edine. He says that does the amount of water on Earth remain the same, or is there any leakage into outer space? Where does the water that has melted from the polarized caps go, especially considering the noticeable droughts in Africa? Is this related to gases that directly affect the ozone layer? Okay, there are so many questions actually in one question.
Yeah, I may not able to respond because this is a very planetary science related questions. So I'm afraid I will not able to do justice
Right.
with my response. Yeah.
Right. Yeah, there is one question by Dr. Rekha Gagoi. Yes, she says that in a global context, where do you think India stands in terms of implementing an early warning system that effectively builds public trust?
Yes, Rekha, for certain hazards, certain early warning system, yes, India has a extremely good reputation. If I cite two examples, one is Cyclone Biparjoy. I think Dr. Mahapatra will speak. This was a very complex tropical cyclone. It was moving at a very slow speed and changing the track rapidly. But our cyclone preparedness, early warning, and the response was so good that Biparjoy was the slowest moving tropical cyclone in the in the Arabian Sea, and deadly. Because slow moving means the wind will stay in a city for a very long time. Despite all the complexities, there was a zero casualty, and the whole world, in fact, recognized this. That was the time when G20 was going on. I was part of the G20 working group from the UN side, and the way everybody recognized this India's capacity of managing cyclone Biparjoy, it was applauded in a big way. So that is something like a real bright spot. On the other hand, when this Wayanad earthquake happened, Wayanad landslide happened, with such a massive, the impact, loss of life, the huge economic impact. There was also some kind of a concern that we could have done better in a terrain like Wayanad, with so much settlement, urbanization, all kind of commercial activities. Government could have been a little more, sensitive to this. So we have mixed bag. For tropical cyclone, we are now the champion with the zero mortality for such a deadly cyclone like Biparjoy. At the same time, for landslide, we have long way to go.
Right. Thank you, sir. Just one more question, last question. It says, so anonymous is written. So it says, what is the most significant climate risk that the world is facing today?
In my opinion, it's a heat. Heat in atmosphere, heat in the ocean, heat on the land. So it's heat all around. So the planet, when it becomes hotter and hotter, its implications to human being, to the ecosystem, to the livestock is still, not very well known, not established. So this is the most dangerous part of the climate change impact.
Yeah. Thank you. I think, sir, we have almost taken all the major questions, unique questions that has come. And thank you for very patiently answering to all the questions. And
Thank you.
so I think we'll conclude. And at the end, I will like to really thank you very sincerely, sir, for this very informative and timely talk that has covered the need for comprehensive disaster risk reduction plans and integrating integrating climate and DRS strategies and the advanced technologies. Thank you very much, sir, for sparing your valuable time, and we look forward to have you among us in near future. I'm really hopeful that on someday we will get you physically here at NESEC. At NESEC, we have a node called Northeastern Regional Node for Disaster Risk Reduction. We are trying to address all the major disasters that the Northeast region basically is affected. But as you know, Northeast region has a huge international border, and therefore we are impacted by what is happening on the other side of the border very much. So it will be really great to have you here and learn more on these aspects. So thank you very much, sir. And I also thank SP Aggarwal sir, chair of the ISPRS TC V Working Group 4, for his continued guidance and support to plan for this webinar. And today we have a very good beginning, but we have miles to go. And I also thank Marcus, who is not online, and Lakshmi, who is from the ISPRS Student Consortium, for their continued support to put the webinar details on ISPRS website, sending mass emails and setting the links right in a very short notice, actually. Thank you very much, Lakshmi, and look forward for your kind support for the upcoming lectures as well. And finally, I thank all the participants for attending this lecture and interacting very actively. So for your information, the next lecture in this series is on 28th February at 10 UTC, 3:30 p.m. Indian time. And hope to see you all again on 28th. So thank you all. Have a good day.
Thank you. Thank you, sir.
Thank you. Thank you.
Thank you.